Hello and welcome everyone. Very happy that we are all together again. In this tutorial we will continue talking about the overcurrent relay settings. So fasten your belt and let's get started. The aim of this tutorial is to learn how to select the suitable time dial setting for the relay to detect the suitable delay time before the relay can trip the circuit. So let's go ahead. First of all, if we need to revise what was the time dial setting, we say it's the relation between the current and the time by which we can select the delay time after which the relay will give the order to trip the circuit. For example, we have here those 12 curves from 0.5 till 11 as a relation between the time and the fault current. And each relay will work according to a relation between them or according to one curve of them as a relation between the time and the current. So each relation between the current and the time represents a time dial. And now we can take an example to apply on that concept. Suppose we have a fault through a specific part of a network, and when the fault current passes through the current transformer, it reaches the secondary coil of the current transformer to P16 ampere. So the secondary coil current is 16 ampere, or the current that will reach the overcurrent relay is 16 ampere. And the pickup current of that relay equals 4 amperes, and also we will use a time dial setting of 3. So we will select the fourth curve which have the number 3 as a relation between the current and the time delay. Very good. Now the first thing to do is to calculate the plug multiplier setting of the multiple of taps. As we learned it before, the plug multiplier setting equals the short circuit current through the secondary over the pickup current. So both of them are given in the example, hence it's equals 16 over 4, which gives 4 taps. Now after detecting the multiple of taps, we can easily specify it to P4 on the x-axis, and we go up to C, the intersection point with the time dial setting of 3. And in that case, we will get the y-axis to detect the corresponding time to P1 second. So this means when the relay has a plug multiplier setting of 4, it will wait a time of 1 second before clearing the fault, and this is also by assuming that the time dial setting is 3, or the curve that we will work according to is the fourth curve. Alright, but you may notice in that example that the time dial setting is specified by default, so we didn't specify it ourselves. And now we need to discuss another example at which we will know how to specify the time dial setting ourselves. Here, suppose we have that simple network at which we have those two overcurrent relays, and the fault occurs at the end of the transmission lines. So we need to calculate the time delay after which each of those two relays will break the circuit, and for the first glance we say that the first relay must have a smaller time delay than the second relay, and this is because R1 will work as a primary protection while R2 will work as a secondary protection. And now the givens are stated in the network. Here the fault current equals 1000 ampere, and also the first current transformer has a transformation ratio of 100 to 5, and its pickup current equals 5 ampere, and its time dial setting equals 1, which means we will detect the relation between the fault current and the delay time from the curve number 1. And for the second current transformer, its transformation ratio equals 200 to 5, and its secondary pickup current equals also 5 amperes. But its time dial setting now is not specified, and this means our aim of this problem is to calculate the delay time for the first relay and to calculate the time dial setting and the delay time for the second relay. Alright, now for the first relay, its pickup current equals 5 amperes, and we can detect the fault current through the secondary of that current transformer to P the primary fault current over the transformation ratio, so it's equal 1000 over 100 over 5, so the secondary fault current equals 50 ampere. And now we are ready to calculate the plug multiplier setting to P the fault current through the secondary over the pickup current of the relay. So it's equal 50 over 5, which gives 10 taps. Hence, the multiple of taps or the plug multiplier setting for the first relay equals 10 taps. And after that, we are ready to calculate the delay time, as we have 10 taps on the x-axis as a fault current, and we choose the curve number 1 as the time dial setting is given in the example to P1. And here you can notice we are using a time dial that gives a smaller delay, as this relay will work as a primary protection. So it's not needed to wait a larger time, as we don't need to make a coordination between it and the other relay, as it will work as a primary protection. And now if we go to the y-axis, we will detect the delay time to be 0.3 seconds. And this means if a full current of 1000 ampere is passing through the network, the first relay at that case will wait of 0.3 seconds before clearing it or before tripping the fault. Very good. Now if we need to detect the second relay delay time, we say that its delay time must be larger than the first relay delay time, and this is because we need to make a coordination between the second relay and the first one. So the second relay will work only if the first relay didn't trip the circuit due to any error into it. And for that reason, the delay time T2 must be larger than the delay time T1 with a responsible period at which the first relay will try to break the circuit. And this time difference equals T2 minus T1, and we select it to be about 0.4 seconds. But if we need to calculate it, it's equal T circuit breaker plus T reset plus T inaccuracy plus T safety margin, where TCP is the time that the circuit breaker consumes to break the circuit by opening its pools, and it's equal about 40 till 100 millisecond. And T reset is the reset time of the relay, as the relay needs a time to reset itself after its working operation, and it ranges from 40 till 70 millisecond. And then the T inaccuracy is the inaccuracy time, which is an additional time that we add as a safety factor, as there may be an error in the calculated time, or the calculated time may be an inaccurate one. So we need to add another time as a compensation for any inaccuracy in the calculated time, and it's about 50 till 100 millisecond. And the last time we have is the safety margin, which we add as a safety for any unpredictable error in the system. Very good. Now we are ready to calculate the second relay delay time. And first of all, its pickup time equals 5 amperes. And its fault current that reaches the secondary equals the pickup current, which is 1000 ampere over the transformation ratio, which equals 200 over 5. So the secondary fault current equals now 25 amperes. And after that, the plug multiplier setting will equal the short circuit current through the secondary over the pickup current. So it's equal 25 over 5, which gives 5 taps. And by detecting the plug multiplier setting of the multiple of taps, but we need now to calculate the time dial setting that makes a difference between the first relay time and the second relay delay time. And for that we can use the second relay time to be that curve number 2, which is that one. And after that we go up from the x-axis at the plug multiplier setting of 5, and we intersect with the curve number 2 at that point. And then we detect the corresponding time to be about 0.7 seconds. And this means the second relay needs about 0.7 seconds to break the circuit in case of the first relay doesn't break the circuit. But also we need to check if that time delay is a good one. And for that we detect the time difference between the first relay and the second one. So it's equal 0.7 minus 0.3, which gives 0.4 seconds. Hence, 0.4 seconds is a good difference between the first relay and the second relay delay time, and by that way we can detect the time dial setting that makes a reasonable difference between the different relays to make the required coordination between them. More than great. So that's about this tutorial at which we have learned how to detect the suitable time dial setting. Hope that's clear right now. Thank you for watching and see you next tutorials.